Good evening. Um, I just kindly remind others to join. Okay, I made a mistake earlier. The link I gave earlier was, I don't know what happened. I downloaded some application and then I linked the application to this live, and the link I got, I don't know what was happening. Everything was just messed up. So I had to I'm no longer using that third party app again. So I'm not using YouTube itself. So those who got the old link, they will not be able to join us. Like by now, I don't know if they are aware say the link has been changed. Oh, we starting already. We are starting already. So those who joined late, I don't know if they know whether the link has been changed. So please, if you guys can hear me, kindly say, type hello if you can hear me. Type hello if you can hear me. Agbona, sir. Agbona. Okay, welcome back. Um, I didn't. That was this Saturday or when was that? Okay, welcome back. Um, was it Saturday? Yeah, I think it was on Saturday. We I think it was on Saturday. We had a meeting that was on statistics. Yeah. And then Sunday was CSM, right? Okay. And then when we did the statistics, no. Yeah, it was statistics, yeah. That was on Saturday, and then we were not able to like really pay attention. Today I intended sharing my screen with you guys, but YouTube doesn't support I mean the mobile one doesn't support screen sharing. So that's why I got the app I was using earlier. But the app, I don't know what's happening. I don't know if it's I don't know. Everything just crashed for me, so I don't know. So, but I'll manage out here. Okay. Now, so far, you guys have done. I'll mention topics, and then if you've done it, you say. Don't say yes. If you say yes, it will sound some. It will be like. So you just write. Just write why. Just why for me. I want to see. Have you done binomial distribution? Have you done binomial distribution? Just write y. Just single letter y. Have you done binomial distribution? Okay, good. Okay, it's fine. Have you done Poisson distribution? Poisson distribution. Who is Phil? Oh, I see. That's nice. Okay. You've done Poisson distribution. So have you done normal and standard normal distribution? Normal and standard normal distribution. Normal and standard normal distribution. Okay. It's fine. Now, I want to ask another question. This time, you don't use y for me. Use maybe just use a, just letter A for me to answer that particular question I want to ask you. I know why I'm doing that. So I want to ask another question, but you are just going to use letter A to respond. Okay, if it is true, you use letter A to respond. If it is a yes, use letter A to respond. If it is a yes, I mean. Have you guys done central confidence intervals for mean? Have you done confidence intervals for mean? Confidence intervals for mean? No, right? If it is yes, you say A. If it is no, you say B. If it is yes, you say A. If it is no, you say B. I mean, if you've done confidence interval for mean, if it's a yes, you say A. If it's a no, you say B. Okay. I know what I want to achieve with my mode of asking question. I know why I'm asking you such question. I'm talking about confidence interval for mean, and standard deviation. But let me say confidence interval for mean because that's the starting point of confidence interval. If it's a yes, you say yes. If it's a no, you say B. Okay. So I can see some A's and some B's. So that means some classes have done it and some classes haven't, right? Okay. Now this is the apple. Listen attentively. You see, when you are going to write mid-semester, particularly mid-semester, okay, when you are going to write mid-semester, in most cases, okay, I'm not one, like not certainty, but in most cases, when you are going to write mid-semester, and let's say multiple departments, several departments, like 10 departments and the likes, you are all doing the same course and you are going to write the same exams. If some classes haven't done certain topic, you see, some classes that have treated the confidence interval, the lecturer is just going like so that I can cover the syllable. But if some classes haven't done confidence interval, the probability that that confidence interval will come in the midterm is extremely low. Are you guys getting me? If you are getting me, say yeah. you are getting me, say yeah. Good. Yeah. The probability that a topic that all classes, since you are all going to write the same exams, a topic that not all classes have done, only some classes have. From my experience, from what I know, from my direct observation in Act 12 verse 10, from my direct from my experience, from what I know, if about 7 classes are doing the same course, a particular course, and they are writing the same exams for that course, and some classes haven't treated a particular topic and some other classes have, the probability that that particular topic will come, it's extremely low, unless it's end of sem. Yeah, whether you've treated it or not, since it's part of the agenda for the semester, it will definitely come. Do you get it? But like, let's say hypothesis testing, maybe some classes didn't do it. As far as it's end of sem, it doesn't concern them, it will come. But for mid sem, yeah, it's not that way giddy giddy. So you see, that's why I've been crying. I've been saying it on what's the name? On WhatsApp. I've been telling you guys that focus on binomial distribution, Poisson distribution, and normal and standard. That one cry, you people know they sit up like the normal and the standard normal distribution, and you are coming to disturb yourself for confidence interval for mid sem. Hey, blah. Don't do that. Oh. Make sure you master binomial, Poisson, and normal and standard normal distribution. Those three topics are, at least master them. Even if you want to study further, you want to learn the confidence interval in case it comes, fine. But the first 3, yeah. So you people should relax, okay. You the Bob. The thing, try and master binomial, Poisson, and normal and standard normal distribution. Is that okay? Even if you want to learn confidence interval has like some parts that is like explanatory, not calculation. Fine, you can read that part to have an idea about what it's about. Because I remember that was last 2 years. There was just one confidence interval question in the midterm. Just one out of about, was it 40 questions or 30 questions? They had just one question on confidence, and it wasn't calculation question, but it was a confidence interval question, but not calculation. You get it? So, like, master, like, don't don't go and learn what to not come. Okay. Don't go and learn what to not come. So, master. You can even this night you can use it to master the binomial, Poisson, and the normal and standard normal distribution. And then I posted some link to a video that was this afternoon also. So those who don't have it, you can ask your colleagues for it. Okay, you can ask your colleagues for it, and then you guys should watch it. I saw a lot of questions for binomial, Poisson, and some of the papers you guys are holding that like you are looking for solutions to. All the solutions are in that particular video. It contains binomial, Poisson, and standard and blah blah. So let's take some question and then treat it together. Now, since I'm unable to share my screen, like it go hard, but we'll try. You will try. So let me read a question to you. I know why I want to read this question to you, and then you're going to give me a response to it. Fikamada. Okay. Okay, so okay, let's have this. Write it down, okay. Someone can also write in the comment section. Yeah, we'll solve it. Don't worry. I'll guide you on how to solve it. It's just a normal question. I feel like, say, okay, they can ask you something like this. If they ask you, how do you approach it? You see, when they are solving questions with you in class, say they solve it like the ones you get in like what if? No pressure. Yeah, it's not that you heard most or every time. Yeah, the questions not necessarily. Bloomer has so many questions. When you open Bloomer, there are so many questions there, but it doesn't mean they will pick all. Do you get it? And then there are some questions in Bloomer that are non-seller to your level. So if you don't know that, like if you don't know the ones that are like possible questions they can set, you just end up solving a lot of unnecessary questions. I don't know if you get what I'm trying to say. Let me make this point clear. Every year, the lecturers themselves have been telling the students that I'm setting questions from Blueman, so go and solve questions in Blueman. And here lies the case. You've gone to Blueman, and there are so many questions there. Some of the questions in Blueman too are non-seller. Should I even call them non-seller or non-co? Do you get it? So how do you know the precise ones to solve in Blueman? There are many questions in Blueman. You get it? So you don't just take Blueman also and start solving all the questions inside. You end up wasting time. Do you get it? You will end up wasting time. That's why I compiled a video, picked some particular questions that have high probability of coming. High probability, I mean. You get it? Yeah. So I hope you get my point clear now. So please, I'm reading this question, so you can write it down as well. Find a z value. Find a z value. Yeah, application questions. Find a z value. Application questions are questions like Theo. Questions like the one it's in the video I said you guys should watch. Questions like maybe a marketing blah blah receives maybe 2 calls per hour on its toll-free number. Those questions that are like case studies. Those are practical questions. I hope you are getting it right. I'm reading a question out to you guys, so kindly write it, okay? I want someone to also write it in. I want someone to also write it in their way, in the comment room. Find a z value to the right of the mean so that find a z value to the right of the mean so that find a z value to the right of the mean so that find a z value to the right of the mean so that find a z value to the right of the mean. To the right, so underline that word, to the right. It's going to guide us on how to approach that question. Find a z value to the right of the mean so that 54.78% so that 54.78% of the area under the distribution curve lies to the left of it. Lies to the left of it. Find the z value to the right of the mean so that 54.78% of the area under the distribution curve lies to the left of it. Who is writing it in the comment room? Find the z value to the right of the mean so that 54.78% of the area under the distribution lies to the left of it. Now, this is how to approach this question. Kindly pay attention. Oh. Pay attention. Attention, please. Now, this is how you approach it. The first thing you're going to do, this question is not asking you to find the area or probability. It's rather asking you to find the z-score, meaning he has given you the area or the probability to the right, asking you to find the z-score that corresponds to it. It is asking you to find the z-score that corresponds to that 54.78%. Are you with me? So, if that is the case, this is what we are going to do. Pay attention. Oh. You are going to take the 54.78%. You divide it by 100. You are going to convert it to decimals. You convert the 54.78% to decimal. So, 54.78 divided by 100. What do you get? You have to get it in 4 decimal places. What do you get? 54.78 divided by 100. What do you get? I'm waiting for your answer. So 54.78 divided by 100. Okay, 0.5478. Is that not it? Yeah, 0.5478. Good. Now, pay attention. Oh. This is what you're going to do. Now, you are going to take your z table. You take your z table. Okay. Now, on the z table, you are not going to look at the horizontal and the vertical this thing on the z table. You are coming to look for 0.5478 at the middle of the z table. You see those probability values at the middle. Those probability values at the middle. I'm coming. Let me show you what I'm talking about. A minute. Let me show you what I'm talking about. Where's my z table self? Z table. Z table. You guys are laughing at me. It's normal. It's normal. C'est normal. Okay, I have the z table here. Oh, this is not showing. So you guys are going to look for it at the middle here, not the side one, not oh, I'm trying to make this look clearer. Okay, not the side ones, not the top and the side. You are coming to look for 0.5478 at the middle here. So wherever you locate it, but you use the positive table. So this is the positive table. So you look for 0.5478 at the middle. Wherever you locate it, then that's what you use to know what the z-score will be. Okay, so 0.5478, this is 0.5478. See, this is 0.5478. This is it. What does it correspond to? This is 0.5478. What does it correspond to? Have you seen 0.5478? So when you trace it, you will see that on the y side, y-axis side corresponds to 0.1. And this side is 2. So that means 0.12. You see? So that's the z-score that it corresponds to. Okay. So at the left, no, you remember this area means area to the left. So the 0.5478 is the area to the left. So it corresponds to a z-score of what? 0.12. So 0.12 is the answer. I think I saw a question like this also in the distance. I hope you guys get it right. Do you get it? Okay. Good. I like your question. Someone is asking me, say, are they going to provide a z-score, z-table in the exams room? Yeah, they will give it to you. They will when they are sharing the question paper. The phone I'm using, the phone I was projecting the thing with, it's not the phone I'm using for the live video. It's a different phone. So this is the thing. When you go to exams room, when they are sharing the question paper and whatever, they will give you to print and bring your own z table there. It's not gonna be small. People have magics of writing things on papers. So if you have your own ways of writing. Okay. Now I said earlier, who can remind us of the question? Who can write the question back? The question was that we should find the z-score, find the z-value. Find the z-value to the right of the mean. Okay. Find the z-value to the right of the mean so that 54.78% of the area under the distribution curve lies to the left of it. So meaning the 54.78% is the area to the left. So we want to know the z-score that it will correspond to. I said, Kojo, were you here when I said, don't be bothered about confidence interval. If you waste your time too much on it, you see simple binomial and Poisson questions, then you get it. So don't be too bothered about it. I'm not saying it will not come per se. I'm not saying it won't come. But what I'm trying to let you know is that there are so many classes, or there are some classes who haven't, like, they've not done the confidence interval yet. Maybe they are still on standard normal distribution. And any topic that hasn't been treated by all classes has a very low probability, extreme low probability of what? Of coming in the exam. You get it? I'm speaking from experience. I was also a student like you. You get it? And not just a student, someone who has been like, just what I'm doing with you, I've done it with so many like students to final years and the likes. So I know what I'm talking about. So it is better to master binomial, Poisson, and normal distribution and have something good to write rather than wasting time on confidence interval and not studying the binomial and those things. Well, then you go to exams and you go and see them baby. Do you get it? So please don't die, okay? All right. Don't die. Don't be, you people shouldn't be complaining about situations. You are in it already, so you have to fight your way out of it. Do you get it? Don't complain about situations. You get it? You have to be confident. You have to be like ready. You have to be ready for the battle. The battle is the Lord's. The battery is the Lord's. Okay. When you find yourself in situations, you are in it already. There's nothing you can do. So just find a way of encouraging yourself to go through that situation. You get it? Now let's take another one again. Let's try and see. Find a z value. Find a z value. Find the z value. Find the z value. Find the z value to the left of the mean. The first one was like to the right of the mean, but this one is saying to the left of the mean. Find the z value to the left of the mean. Find the z value to the left of the mean. So this tells you that, the mean is always at the middle. Remember, the first z we got was at the right of the mean. It was at your right. So this z you are going to get will be at your left. It must be a negative z. That's what it tells you. That z must be a negative value. So that's a clue. To the left of the mean. The mean is at the middle. So your left is going to be a negative value and your right is going to be a positive value. So let's complete the question. Find a z value to the left of the mean so that 98.87% of the area under the distribution curve lies to the right of it. Someone should, all those who have written it, put it down in the comment. Let me see. Find a z value to the left of the mean so that 98.87% of the area under the distribution curve lies to the right of it. Lies to the right of it. Lies to the right of it. Sin. Okay, so let's see how to approach this. Now this is the thing here. What should come to mind is this z value is going to be at the left of the mean. You remember you were taught that the mean is at the middle of the curve. So the left will be a negative value, the right will be a positive value. So this one is simple also. This one you can check it on the positive table also, but make sure your z is a negative answer since it's at the left. You can use the positive table to also check it, but you just attach a negative value to it. So let's see how to do that. So what you do first is you convert the 98.87% to decimals. So do 98.87 divided by 100. 98.87 divided by 100. What do you get? You get 0.9887. Good. So this 0.9887, we are going to check it at the middle of the table. You take the positive table now. Don't worry about the negative one. Take the positive table now. Check 0.1 with 9887 at the middle. Then you check the value it corresponds to. 0.9887. It should give you something like 2 point something. 2.33 or so. It should give you 2.33 or something that way, yeah. You are laughing at me, your face. Look at this. The 9887. You are going to look for it at the middle here. Okay. You look for it at the middle. So we are checking for 0.9887. So let's check. 0.9887. 9887. See, in this. Come on. This is it. 0.9887. It corresponds to 2.3. Yeah, it corresponds to 2.2 something. 2.28. It corresponds to 2.28. Yeah. 0.9887. You just look for it on your table. You will say this is it. This is it. 0.9887. So this 0. Good. I forgot to tell you something. Pay attention. Oh. If you are checking certain tables, you see that they've written 0.9887 instead of 0.9887. In maths, I can write 0.12 as 0.12 without writing the 0. So don't always expect to see 0 before the point. As soon as you say point something, you should know it's 0 point that thing. Okay. No calculator trick. You can actually find this z table on calculator, but you doing this on calculator is a waste of time because they will give you the table. You can use the table to check it straight. You get it? So this is 0.9887. It corresponds to 2.28. But 2.28 is not the answer because the question says to the left of the mean. You know, the left of the mean is a negative value and the right of the mean is a positive value. So it has to be negative 2.28. Not positive, but negative 2.28. I hope you guys get it. Do you get it? Negative 2.28. Let's proceed. I have no time. I just wanted to discuss some important things with you guys before you go and watch the videos. That's why I organized the meeting. Now, take this question. Someone should write it down. Someone should write this question down. You all should write it down. Which of these confidence intervals? Remember, I told you they don't set confidence interval questions giddy giddy. If they want to give you confidence interval question, it's just a minor one, be like what I'm reading to you right now. Okay, just some minor one, be like what I'm about to read to you right now. We actually check it on positive table. Okay, you retracted the message. You realize it. Okay. Okay, please pay attention. Oh. I said, and I repeat, that they don't really set confidence interval questions in midterm because not all classes have done it. But in case you will see any question on confidence interval, it's just some like minor ones, be like not calculation po. Do you get it? So the type that you can see is what I'm about to read to you. You get it? Uh-huh. Today I won't mind you people because I'm hot. Is that okay? Can you hear me now? Please, can you guys hear me? Say hi if you can hear me. Can you guys hear me? Okay. Hey, Faith says he is mine, please. Okay. Yeah. I won't complete the sentence. Let's continue. Which of these confidence intervals will be the widest? Which of these confidence intervals will be the widest? I expect someone to write the question down for me in the comment section. Which of these confidence intervals will be the widest? A, 90%, B, 95%, C, 97%, and D, 99%, sorry. Which of these confidence intervals will be the widest? A, 90%, B, 95%, C, 97%, and D, 99%. Which of these confidence intervals will be the widest? Wide. Which of these confidence intervals will be the widest? A. So I'm giving the possible answers. A, 90%, B, 95%, C, 97%, and D 99%. Now, let me tell you some rule, okay? You see, the higher your confidence interval, the wider the interval. So let's say, let's check this. Let's assume that standard deviation is let's assume that margin of error is, let's say, 2. Okay, let's assume margin of error is am I saying 2? Let's assume margin of error is 0.5. Let's assume margin of error is 0.5, and let's assume mean is 20. If you take z-score of 1, okay, if you take z-score of 1 times 0.5 is 0.5 plus 20, it will give you 20.5. But if you take a z-score of 2 times 0.5 is 1. When you add it to 20, to give you 21. So you see that the higher the confidence intervals, the higher the confidence interval you choose, the wider the intervals. If your confidence is high, then you have more wider interval. Do you get it? So the correct answer is 99%. 99% will be the widest, because the higher your confidence interval, write it down, the higher your confidence interval, confidence level or confidence interval, the higher the intervals. The more confident you are, the widest the interval will be. Is that okay? Yeah. I hope you guys get it. Thumbs up if you get this one. It can, if it's a confidence interval question, but it doesn't mean it will come per se, but like. Okay, let's take this question. It can also come. Let's quickly take another question. Pay attention. Oh. Are you ready? It can. I'm not certain, but there's a high probability that you can see same question. You ready? Okay. A fair coin is tossed. Relax, it's not last semester question. You will see. A fair coin is tossed 5 times. A fair coin is tossed 5 times. A fair coin is tossed 5 times, and the number of heads recorded. Can you guys hear me? Hey, can you guys hear me? Okay, good. If you can hear me now. I was scared. I thought it's my data bundle that got finished. I'll be like, hey, why are they drinking the data bundle? All right. Okay, so I'm reading. Attention, class. A fair coin is tossed 5 times, and the number of heads recorded. A fair coin is tossed 5 times. 5 times, baby. Sorry, excuse me. A fair coin is tossed 5 times, and the number of heads recorded. Full stop. Find the standard deviation for the number of heads that will be recorded. Hey, you guys, your ears are sharp. Oh. Can you hear me now? A fair coin is tossed 5 times. Someone should paste the question. We listen, we don't judge. Okay, can you guys hear me now? Those who weren't hearing me, can you hear me now? A fair coin is tossed 5 times, and the number of heads recorded. Find the standard deviation of the number of heads that will be recorded. Oh. I wanted to be sure if the problem is coming from me or something. That was why I was asking you guys, can you hear me? So I don't know if the network, I don't know if the network is twerking at Abel's side or at my side. Okay. Then the network is twerking at Abel's side. Okay. So how do we solve this question? So let's see. This is simple. Okay. If I ask you what is the n? Okay, sharp, sharp. Yeah, let's do it sharp, sharp. Well, I think it's only human being at work. Network to twice. A fair coin is tossed 5 times. So the n, the small letter n, the sample size is 5. Is that okay? The sample size is 5. Now, let me ask you guys a question. What is the probability of success in tossing a coin? This is where the problem is. Oh. You see, the question hasn't given you. Do you know that to find standard deviation, what's the formula for finding standard deviation in this question? It is n times p times what? Times q. Where q is 1 minus p. Somebody should write it down. The formula for standard deviation is n times p times q. N times p times q. Write the formula down. N times p times q. N times p times q. Good. And it is important you know, say q is equal to 1 minus p. It is important you understand that q is equal to 1 minus p. Is that okay? That one you have to know it. Okay. Where p is the probability of success, q is probability of failure, and n is the number of trials. Now, in statistics or probability, when we say success doesn't mean the thing should be good always. Even if something is bad, it could be a success to us. If we want to arrest a criminal and we get the criminal arrested, it's a success to us, but it's a failure to that criminal because we got him arrested. So don't look at don't mind the body, you have to mind the engine. You get it? So Q is the probability of failure. Good. Now let me ask you, in tossing a coin, what is the probability of a success in tossing a coin? When you toss a coin once, what is the probability of success in it? You know, there are 2 possible outcomes in tossing a coin. And what are those outcomes? Either you get a head or a tail. So if you get a tail, then the probability of getting a tail is just one tail in it over the sample size, the number of possible outcomes, which is 2. That's 1 over 2, which is 0.5 in decimal. You get it? So probability of a single success is 0.5 in this case. You get it? So our p is 0.5 and our q is also going to be 0.5. And our n is what? 5. So 5 times 0.5 times 0.5. 5 times 0.5 times 0.5 will give us what? 5 times 0.5 will give us 2.5 times another 0.5. What do you get? 1.25. So the standard deviation is 1.25. So in the possible answer, you see something like A, 1.12, B, 1.25, C, 2.00, and D, 2.50. So the answer is 1.25. Okay, let's take another question. Hey, thank you. What we got, 1.25 is the variance. N times P times Q is the variance. Hey, me pa. N times P times Q is the variance, right? But we take the square root of it to get the standard deviation. N times P times Q is just the variance. Okay, n times p times q is the variance. That's 5 times 0.5 times 0.5 is the variance. But when you find the square root of the variance, you get the standard deviation. So find the square root for us. Let's see. What do you get? Yeah, I'm tired. I came back from work around 6. Is it 6 or 7? Yeah, 6. Let's quickly take this question. I don't expect this question, but it was given last year and last 2 years. I wasn't expecting. I don't expect it to be come by. It was given last year and last 2 years. Yeah, I know. Let's take this. What value of the population proportion P? What value? Let's take this last one. What value of the population proportion P? What value of the population proportion P will maximize? What value of the population proportion P will maximize? What value of the population proportion? After writing population proportion, then you write P, then you continue. Will maximize. Someone is asking what of the mean. The mean is just n times p. That is 5 times 0.5. That will give you 2.5. That's the mean. Okay. N times p is the mean. Then the variance is n times p times q. And the standard deviation, you square the variance. So I'm reading another question. What value of the population proportion p will maximize p into bracket 1 minus p? What value of the population proportion p will maximize p into bracket 1 minus p? This came last year and it came last 2 years also. Okay, I'm coming in. What value of the population proportion p will maximize p into bracket 1 minus p? This one, the answer is 0.5. Okay, the answer is 0.5. There's a way I'm supposed to prove it, but if I'm to prove it, I have to take pen and solve for you guys, which is not. I think it's something you can easily remember. The value of population proportion p that maximizes p into bracket 1 minus p is 0.50. Is 0.50. That's what maximizes it. Okay, I hope you guys get the answer right. I said the answer is 0.50. So when you see such question, you should know say the answer is 0.20. Okay. Yeah, the video I asked you guys to watch, I think I solved it inside. So let me send you the link again so that you check. It's inside. It's inside. And then after this thing, you guys should prepare for the CSM. After the start exams tomorrow, it's not going to be giddy giddy how you guys are afraid and then you are shaking. No, just solve the normal past questions and whatever you guys have. Just solve them, and that's all. You are good to go. Solve the past questions, and then maybe the blue man also, you get some questions from there and solve. But not all questions in blue man under a particular topic will come. There are some that they can't even set them. They are just there for trial, like for trying yourself. They can't come in exams. Huh. Yeah, everything was recorded. I've recorded everything, so you can replay. So I those in a group, no, I posted a link, and I keep pointing to that link that you guys should watch that particular video. But I don't know if you guys have done it. Have you watched that video? I want to see your thumbs up if you've watched the video I'm talking about. I kept, like, I've been pointing at a particular video that you guys should watch it. Watch it. I've repeated it multiple times. I have my reasons for that. At least I've explained how to solve most of the questions there. So it gives you a deeper understanding. Nah, the Blue Man question is not just a question. It's not Blue Man question. No. The thing is a book, a textbook. Blue Man is a textbook. You can get it online. Just type Blue Man Statistics PDF. It's a book. You can get it and download online. But the issue here is that, you see, in Blue Man, at the end of every topic, this Blue Man thing, you guys need to get it clear. Don't just say because they say you should solve Blue Man, then you are going to solve Blue Man. You just end up wasting time. Those who have opened Blue Man before, they understand what I'm talking about. The Blue Man, at the end of every topic, there are several questions on that particular topic. Like, you see so many questions. So do you think the lecturer will go and pack all the questions under a topic? Like, you've done 3 topics, then he will pack all the... No. They are picking some of them randomly. And in fact, there are some sections of Blue Man question that you can never see in exams. Your exams, your level exams, you can see them. Under that same topic that you've done, under binomial Poisson, there are some binomial Poisson questions that they can't even set for you guys. But it's in Blue Man also. So what if you go and waste time solving those ones? What if you don't know that those ones can't come, and then you go and waste time solving them? So that's why, like, sometimes the past questions you guys are solving or whatever, they are also from Blue Man. So you can use those ones as guide to know how the questions look like. So that when you are solving the Blue Man also, you know the kind of questions to approach and the ones to ignore. You get it? Huh. So it's Blue Man. Okay, so please, I've posted a video for you guys to watch. I repeat, let me check it. Yeah, I did. So that's it. And then after the start, you guys should prepare for CSM. Is that okay? After the start, you prepare for CSM. So I'm leaving now. You have like I think the video is not up to 2 hours, or it's just 1 hour. So you guys should try and then go through it. Do you have any question before I close the page in the meeting? Like normal question, like not the exam question, like something related to the exams. Yeah, I told you guys not to like shiver, like don't fear, like it's normal, like just normal questions that you are going to see. If you raise your expectation too high, or don't panic, let me put it that way, and then don't solve big questions, then you're going to be seeing minor petty questions, then you'll be able to solve. You see that thing? Sometimes you're going to be solving big questions, then you go to exams, then you're going to see petty questions. Swapping. How much you go pay? Okay, you have com skills the same day. I never knew you have com skills. So I don't think you guys will write. Okay, you write it in the lab, right? You guys will write it in the lab, right? The com skills, now you're writing it in the lab. What time is the com skills? What time is the com skills? What time is it? 2 p.m. And what time is the start? What time is the statistics? 8. So you guys, after the statistics, we'll meet. We'll have small discussion on com skills. So get ready for that. Is that fine? Thumbs up if that's cool by you. Set statistics is 8:15 a.m. So 8:15 to 9:15. Quickly get back to your hostel and go and eat some gobe. After gobeing yourself, then we'll do some 1 hour for com skills. Okay. Is that okay? Okay, it varies. Yeah, that's true. Someone's one is at 11. That's true. I remember it varies. Oh, then how are we going to do this? Let me see. 8. Okay, let's see. 8. The first paper is 8 to 9, right? 8 to 9:15. So what I'll do is that I'll start it at 9:30. Okay. I'll start at 9. Even if you are not at your hostel, you take your hands-free or earpiece or AirPod along wherever you are going, so that when you close from lectures and you are not at the hostel yet before I start on point, you can use your AirPod and then be listening. It's just listening. You are just going to listen. So okay, is that fine by you guys? Thumbs up if that's okay. So 9:30, I'll start. 9:30, I'll start. Then by 10:10, then I'm done. Okay. And then I think I did some com skills video last year, but it's not enough. It wasn't too rich like that. But you guys can go through that one as well. Okay. All right. So I'll post the link. I've reposted the link. So those of you in the group, send it to your colleagues. Yeah, it's normal. I deliberately set it that way. Why you want to see me? They play. You wanted to see me, Anna. Amen. We'll all be great, okay? So those of you in the group, forward it to your colleagues, because I know some of them are not in the group. I should show my face now. You will see me on campus when I'm around, but on social media, or how do you call, you won't see me. Okay, I've heard you. Why? No, we'll do it. I've sent a video that you guys should watch. Okay, I've sent a video to the group that you guys should watch. The video actually explains certain concepts, like at least even if you don't see the same question per, you see something related, at least you'll be able to solve it because you understand the concept. Do you get it? But I'm sure that's how the questions are going to look like. So how will you identify me? Somebody would, the continuing students know me, so they will definitely mention my name, so you will know I'm the one. The continuous and the level 300, 400, 500, 200. Okay, level 200s. Okay, some of them also know me, so yeah, they all know me. So when maybe they will mention my name when they see me on campus, then you will see that I'm the one. Faith, don't mind them, okay? Yeah, sharp. So after the mistake, you guys should remind me or else I'll forget. Remind me. Early in the morning or around let me say 7, or remind me that Philos, we are meeting at 9:30. I'm not Sarah. I'm not. Oh. Oh no, I'm not. I'm not. Yeah. Listen, probability you get between 0 and 1. That is right. But standard deviation and mean, they are not guided by that rule of between 0 and 1. You can get anything as a standard deviation. You can get anything as a mean. Mean and standard deviation are not between 0 and 1. It's only probability that is between 0 and 1. Only probability. Even z-score is not between 0 and 1. Z-score can be anything. It can be more than 1. It can be negative. It can be 0. It can be between 0 and 1. It can be more than 1. It's only probability. Keep it. That it's only probability and nothing else. Just probability per and nothing else can be between 0 and 1. Only probability has value between 0 and 1. The rest, they are on their own. Like how you are on your own. You get it? Yeah. Yeah, I'm done. Okay. So, see you guys. Bye bye.